let's look at another example. Let's say I have a 3-bit converters. With sampling and hold. So full scale 0 to 10 volt. So you have analog voltage coming in at 6.115 volt. So through the sampling and hold every time, so what will be the digital voltage? And what will be the corresponding binary code, binary numbers? Let's start with if the converter only has 3 bits. Well, first of all, if I only have 3 bits, what's the resolutions? Resolution will be total full scale range divided by the number n bit can represent. It's 2 raised to the 3rd power. So what does this mean? Meaning between 0 to 10, between 0 to 10, we divide this by 8. So the increment will be 1.25, 2.5, 3.75, and 5.0, 6.25, 7.5, 8.75. So the digital voltage will be only on these numbers, one of these numbers. However, analog voltage can be any numbers. Okay, so in this case, it's 6.115. 6.115 is right here. So what will be the corresponding voltage? Got to be somehow below between 5 and 6.25. We pick the one, pick the smaller below. Remember we compare using the comparator, compare them. So your digital voltage is 5 volt. Of course, you have 1, 2, 3, 4, 5, 6, 7, 8. 8 number you represent in binary 3 bit. You have 3, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1. So of course the corresponding binary code would be 100. Okay. However, this is, since the m is equal to 3, is easy to do. Even we can break it into 8 and then pick the numbers. What happens if I have 10 bit or 12 bit? Then what would be the answer then? So in that case, let's say we have n bit. Then we can start, yes, resolutions will be full scale range divided by to the amps. And the step, how many steps? And we can come up with general approach. Will be the voltage analog divided by the resolutions, which should give you some numbers, but make sure your numbers, you should get it. The step got to be an integer, so you should pick the integer, run down. And then the digital voltage will be resolutions times step, how many steps required. And how about the binary? And the binary code will be you take the step and represent step. That's in decimal into binary. So this is general approach. You find the resolution, you find the step, but make sure step itself need to be an integer. And then you need to run down the number. Take the smaller one. Between 5 and 6.25, you pick 5. Okay. So what's the digital voltage? Resolution times the step. And then the corresponding binary, and you can convert the step decimal to binary. So we can check the answer again. Let's say, so for the 3-bit, so resolution 1.25, so step will be 6115, analog divided by the resolution, which is 1.25, get 4.89. So run it down, so 4 steps is 4. So digital voltage will be the resolution times 4, so 5 volt. The binary, so represent 4 decimal number 4 in terms of binary. Two, 1, 0, 2, 0, 1. So least significant bit to most significant bit. So least to most. Bit, so 100, so we should get the same. Least to the most. Same problems if I have 10 bit. So what's the voltage? In that case, what's the resolution? So we have approximate 76. So how many steps? voltage divided analog voltage divided by the resolution. Now we had 626 step, so the digital voltage will be resolution times the step. Binary. So how do we get binary? We put this 626 decimal number in terms of binary number. Keep divided by 2. Ten bit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So least to the most significant bit. Let's double check. 1, 0, 0, 1. So this is zeros 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to the 9, 2 to 6, 2 to 5, 4, 2 to 1. 32 plus 16 plus 2. 18, that's 50, 114, so that's 626. It's the same as ours. 626 step. 626. So this is right. Okay, let's do another example. So next examples, if I have AD conversions, return the code is 0, 1, 1, 0, and this is 8-bit 0 to 5 volt range. It's 1 to 1, there's no amplification. So question is, what is the voltage, analog voltage, and also what's the digital voltage? To have this. So, first of all, it's 8-bit, 1, 2, 3, 4, 5, 6, 7, 8, so it is 8-bit. So, it's 0 to 5 volt for scale, unipolar. So, question is, what is the corresponding digital voltage and what analog voltage to cause this binary number in the digital? So first of all, we know it's 8-bit, so resolutions we can find 5 minus 0, 2 raised to 8. One nine five. Okay, so from this one we know the step. We can find how many steps. So this is 0's power 1, 2, 3, 4, 5, 6, 7. So we can find how many steps. (32) plus 8 plus 4 plus 2a 10 14 46 1110. Check. Plus 32 plus 8 plus 4 plus 2 1110. So you have 110 steps. So you know step, you know resolution. So the digital voltage for this digital numbers will be 0.0195 times step, resolution times step. .145. Okay, we got a digital. So next question is, what is the voltage? What is the voltage, analog voltage, to cause this digital voltage or this binary number? Okay, so then again, analog numbers, analog signals, it's continuous, and digital is discrete in between the resolution, the grid lines. So you have, for example, you have every step resolution, that's 0.95. So from here, you get 2.145. That's 2.145 plus a resolution. So this is digital numbers right here. It's digital voltage. What is the analog voltage? So if your answer is only one number, 2.145, that's wrong. It should be a range. So it should be whatever between these 2 points should be your answers. So analog voltage should be smaller than 2.145 plus a resolution 0.0195. I forgot 5 here. Okay, and also here's 2.145. And if it's equal, you will still reach that point. So equal and smaller. Okay, again, analog voltage is continuous. It could be any numbers in between, so give you the same voltage, digital voltage, and binary numbers. And also digital voltage is discrete. In other words, it's one step only on the grid. From here, jump to next one, jump to next one. There's nothing in between.